All right, in this video, we're going to talk about maps in Go. Maps are sometimes referred to in other programming languages as dictionaries or hash tables. The way you want to think about maps is there's something that you do to look up, and then there's something that you are looking up that's related. So this is going to be a map from strings to integers. In the particular sample program, I'm going to be implementing a shopping cart. So in the shopping cart, we will have items and the quantity of those items. So the item name will be the string, and then the quantity of that item will be the integer. So we can do a loop over one of these maps. We get back all of the names and then all of the integers, and then I'm going to print them out here. So we make to initialize our map. So this is now a map that will have nothing in it. We're going to read from the keyboard, doing this buff.io new scanner on OS standard in. That's going to allow us to read a line at a time from the keyboard. And we'll print out some directions. So you can add something to the cart, you can remove something from the cart, or you can exit. So we ask for a command. If the scanner is done, then we exit. If we get back the text exit, we exit. And now we have a line of text. We're going to split it into fields. So those are separated by spaces. We're expecting three things, right? So it should be add or remove, a quantity, and an item. The item might have spaces in it, so if it's like green apples, so we only check if it's less than 3. We don't check if it's more than 3 and report an error. We then, the action, we convert to lowercase, so you can say add in capital A, all caps, whatever. The quantity is going to be the second thing on the line. And then the remainder of the things on the line we join together, convert it all to lowercase, that's going to be the item name. We're going to use the ASCII to integer from string conversions package. And so this is going to convert the string to an integer base 10, possibly reporting an error, right? If we said like add Bob of bananas, then we'll get back an error. So we check to see if the error is there, or negative numbers are also not okay. So if we get one of those, we'll print out an error message. And then we'll have a switch statement. So we're going to select what to do. If we say add, then we're going to add the value to the quantity for that item. Now, the default value is 0. So if we look up items, let's say we're adding our first thing in the cart, 2 bananas. So cart bananas doesn't actually return an error. It returns 0 if the item is not present. So we can simply add 2 to that and then put that into the cart. And then we'll print out a message. That means that when we want to do remove, we can't just do cart item because we could get back 0 always. So we're going to actually check if something exists. And so if something doesn't exist, then we'll say it's not in the cart. Otherwise, we'll simply subtract that number from the quantity. We're not checking here to see if you put 2 bananas in your cart and try to remove 5. If we do that, then we're just going to remove all the bananas from the cart. And so if your cart ends up with 0 or negative, then we delete the item. That's how we deal with that error case there. So if you added 2 bananas, you say I'm removing 5 bananas, it'll just remove the 2 and not worry about the other 3. And of course, if you don't say add or remove, we'll print out an error saying that you need to do that. And then we print the cart. Once you've said exit or the scanner fails, then it comes down here and says thank you for shopping. So go ahead and run that so you can see what it works. So we say add 2 bananas. So now we've added 2 bananas. There's our current cart. We can add 2 pineapple. We say remove 3 strawberries. And so strawberries is not in your cart. If we say remove 5 bananas, actually let's just remove 1. Now if we said banana, right, banana's not in the cart, we've stored it as bananas. So now we have 1 banana. If we say remove 3 bananas, it says it removed 3, but it really only removes the 1. And I'm going to say exit, and the program completes. So again, maps are really handy. They give us a fast way to look things up. And if you imagine if we tried to implement this with a slice, if we have like 50 things in our cart, we'd have to start at index 0, walk through the slice until we found the thing. Using hash functions, which we'll talk about later, you can go usually directly to where the item is. And so you save a lot of time by using this for fast lookup instead of walking through a slice.